Hello guys, welcome to another video, and this one we're going to talk about cross product. So we have talked about the dot product already, and you know what it does. And there's another operation that's really common, which is called the cross product. And also it's a little bit more mysterious to many people, and let's talk about it, how we can use it and what does it mean. So if you do a cross product of two vectors, let's do v1 and v2 again. Oops, uppercase V. And this cross product will yield another vector. We can call this guy vector v3. Okay, and let's also put that vector at the origin, which means that this coordinate is going to be the end of the this new vector if the root of the vector is at the origin, right? And we can also just add a point to see that. Add a point to the geometry here, and we're adding it to the position of v3. You can see now how we're getting a new point. And just to also see the line there, we can add that line. A line is a primitive in Houdini, and it's a polyline. And then it is from point 0 to point 4. Alright, cool. Now we're having a new line here. And this line basically resembles what vector 3 looks like when it's sitting on the origin, right? So the cross product of v1 and v2, this is v1 and this is v2, right? It's going to be v3, which is this one from point 0 to point 4. Okay, and let's take a look at how they are different when we drag the degrees. All right, when the degree is 0, we're getting nothing, or basically the v3 is 0, 0, 0. When the degree is getting bigger, it's getting longer, but it doesn't change direction, right? It's just getting longer. And when the degree is 90, you can see exactly the end is actually on -1 here, or the length of this vector is 1. Keep on going, it's getting smaller again, and when the direction is like completely facing away, the new vector v3 will be also 0, 0, 0. Now going back from there, it's getting longer again, and again when they're perpendicular, its length becomes 1 again. And also notice that in the middle it kind of like flips the direction, right? And also very interesting result you're seeing here is that this new vector v3 will always, of course if you're not using a 0 degree here, this new vector you're getting is going to be always perpendicular to both v1 and v2, as you can see over here, right? And v1 and v2, they're locked on the xy plane here. I can see v3 is basically the z-axis, right? So long story short, cross product will always give you, not always, if the two vectors, of course, v1 and v2 are not the same direction or the opposite direction. If that's true, then the cross product will give you a vector that is perpendicular to both v1 and v2. Okay. And also the order matters. So here, if you do cross product with v2 first and v1, the result is actually the flipped vector. Okay, and how do you determine that vector or predict the direction of that vector is using a rule called the right hand rule, which is if you align your index finger of your right hand, of course, to v1, and align your middle finger of your right hand to v2, and then your thumb is going to be pointing at the direction of v3 in a relaxed pose, of course. So yeah, that's good. That's going to be how do you predict how this vector will point at. But nonetheless, no matter which direction it's pointing, it's going to be guaranteed to always be perpendicular to v1 and v2. Of course, if those two are not, let's say, parallel, right? Or either in same direction or opposite direction. Yeah, so you can also see that the length of this line changes in the middle, right? So that value actually has some meaning. Here. The length of this line is actually this. Let me actually demonstrate that. Let's go to maybe some degree here. And I'm gonna add vector 1 and vector 2 together and create a new point to form like a parallelogram. So I'm gonna add a new point to the first geometry, and that the location will be v1 plus v2. You can see that's 0.5. I'm also gonna create a parallelogram by adding a primitive. And this time the primitive will be a closed polygon, and it has to use 4 points. So I'm gonna go for 0, 1, 5, and 3. So 0, 1, 5, 3, and that's gonna give me a parallelogram like this. Okay, so the reason I built this guy is because the area of this parallelogram is actually the same length as this vector. And you can already see that in action. If I drag them, make the degree smaller, you can see how the area of the parallelogram getting smaller, while also the line is getting smaller too, right? When they're zero, when they're all zero, right? They're all zero, which is kind of like pretty cool, right? So yeah, the length of this line is basically the same as the area of this parallelogram. Now don't ask me why it's like that. Just try to remember it, because you know it's like math is a religion. You either believe it or not, and knowing the exact reason have lesser merit or zero to nothing really helpful. Like if you just learn the mathematics, you could know like why it's doing that, but that's not really gonna help a whole lot on you're using it. Okay, cool. And we can also just take a look at a particular interesting scenario here. Like here we are having a completely straight angle for all three axes, right? All three vectors. You can already see or tell exactly like the length of this vector is 1. The area of this square is of course 1, because those two vectors v1 and v2 are unit vectors. Their length is 1, right? And of course the area is 1 here, right? That's also resembling what's going on here, right? But primarily you use cross product to get a line that is perpendicular of the two vectors you're doing the cross product. Okay, and it can be really helpful to maybe sometimes you want to move points along the normal direction of a face, right? You can use that, or many possible cases. But just to remember the meaning of the result of cross product and dot product is actually really helpful. And in game programming, those two mathematical calculations are used a lot to to get things done. All right, cool. Thanks for watching. See you next time.